I have something that I like to talk about, and I realize on Zoom, I could probably be showing you a charcoal briquette at this point and making a great story up. So what I did was I took some pictures of this, and I'd like to tell you about a little journey of discovery I made. So is it possible to show like a PowerPoint? Is that okay?
Can try it.
Okay.
That I think Greg would need to. Well, you can try showing it, presenting. If not, Greg sent up. It's working.
Hey.
Good.
All right. So this is what I grabbed. And I want to tell you a little fish story. And I do this with some trepidation because Greg's on the call. I don't think I could match his, but it's more of a journey of discovery here. So I acquired this about a month ago on eBay. And I'm going to show you some additional pictures here of more close views of this.
Oh, that's fun. Yeah.
Now, can you all see that?
Yeah.
Yeah.
Okay, so let me go through a couple different views, showing you some detail here. And as I looked more closely at this, I said, I think this is bone, fossil bone. And here's a little more profile here. This is about 3.5 centimeters wide. I want to show you this picture here because it intrigued me. And originally I thought these grooves were fractures, okay, in the stone itself. But I've come to think it's something else. And so I want to explain a little bit about that. So I said it was a fish story. What are we talking about? Well, I think we're talking about some part of this creature here.
Oh.
No way. That's awesome. Dunkleosteus is cool.
I think you're right. I've come to that conclusion myself. This actually is a reproduction cast of a specimen from the Cleveland Museum of Natural History. This is a picture I took a couple of years ago when I was touring one of the Metro Park's nature centers, and it just blew me away. In fact, let me show you this picture here, which is a 3D model of the fish itself. And just to point out a couple things here, this is a vertebrate, so it's got a spine here, but it's got this big bony head, and it's got a bony pectoral. So there's two on one on each side. Now, unfortunately, when they show pictures, they tend to show these portions of the mouth as white. This fish did not have teeth. This is actually bone, so no dentin. It's basically just bone. And the fish would sharpen these as it closed its jaws. So you can see where these fit in the grooves, okay? So my fish story is about the placoderms, okay? And how this little piece of rock kind of led me on this little journey to learn more about the placoderms. So we're talking about the Devonian period here and the arthrodire. There are many other placoderms, but it would be maybe good to get a little perspective on what this is, because I don't think you could get that from the previous pictures. You could kind of see from this diagram here, this is a big fish, not the kind of thing you want to meet scuba diving. And its size was quite significant. So it was 3 to 6 meters long, or greater than 1 ton, fully grown. The girth at the maximum jaw was 1.3 meters. And the bony plates that made up the skull could be up to 5 centimeters thick. So mine is 3, suggesting if this is correct, this is part of the fish that was still an immature form. And they found specimens of this in the Antarctic And I believe now that the true coloration of this is on the bottom, an iridescent silver, on the top, a red tinged color. And there are some people that even are suggesting this fish might have had color vision. So we're seeing here evolution of the mouth parts, the pectorals, the vision. This is really kind of a significant part of that Devonian evolution. So the logical question I said is like, okay, where are these things? And could this even be found where the person who sold this to me said? So I went back to the Devonian period here, and obviously things weren't quite the same. NA means North America. And the powder blue areas, which are really quite extensive, was the natural environment of this fish. So it was all over the place. It was an apex predator and possibly also a cannibal. So this fish really thrived in these seas for millions of years, and it ate pretty much everything, okay, including other fish. Now there were obviously sharks in that as well. So to maybe give a better, I don't know, perspective, let me show kind of a more modern view of this part of the earth. And what I have on the right side is a Ohio geographic map. But I want to point out here the yellowish orange color area, which is found along the lake shore, then down through Columbus and towards Cincinnati. So this is the Ohio River at the very bottom. And then here is way west, the Toledo area. So it's Toledo, Sandusky, Cleveland, and then over on the side here, Ashtabula, where my specimen came from. So I labeled as A, B, C, and D. So A is where my specimen came from. D is where I did some fossil hunting myself, and I brought in some brachiopods and trilobites and that, all again from this Devonian shale. And then I want to talk a little bit now about C and B. So when we go back a little bit in history, this organism was first discovered, or at least characterized, in the latter part of 1800s here. And a hotel owner found a first specimen walking along the lake shore when he saw some bones in the sea cliffs. And he excavated them and said, hey, this is fossil. And he was smart enough to know that. He was an amateur paleontologist. And his guess was maybe it's a fish, which I thought was interesting. And he said that I need to take this and get some help to interpret it. So here's the historical marker at a location called Sheffield Lake, where the first specimen was found. And it notes here his first name, Dunkleosteus. Well, he found an expert indeed. So he found Dr. Strong Newberry. Now, Dr. Strong Newberry was famous locally during the Civil War era. He was a physician, but he was really a polymath. Okay, he went through medical curriculum at what is now Case Western Reserve, started practice, but volunteered for the Union Army, and then was tasked on a scientific exhibit to go west to do some further exploration on behalf of the National Geographic Survey. So he accompanied some of the military escort out to the west. There is a Oregon link, which just shocked me. So our own Newberry crater carries his name. So Dr. Newberry was the namesake for the Newberry crater, but ironically, he never saw the crater. He never discovered it. It was discovered, obviously, generations earlier by local Indians, but as an honor to him, the crater was named after him. And he first described this specimen in a monograph in 1875, and then further kind of expanded on this in a pretty remarkable work, at least to my novice mind, called Paleozoic Fishes of North America in 1889. Now I want to show you a picture, and this is from the monograph, and the picture of the picture here is actually the original specimen. So this is what stimulated his discussion. And by this time in 1884, many other specimens were found. So he could elaborate on this as well as a lot of other fishes. So I know it's a bit dated, but as I was paging through, I mean, there's just a wealth of information and a testimony to this guy's mind. If you don't mind, I'd like to just for a couple more minutes go a little further here, because I want to bring you current. So as I mentioned before, I kind of grew up in the Cleveland area and knew a bit about the geology and geography, but only as a kid that played in the water. I mean, I really didn't understand what was there. And what has evolved over the last 100 years has been a deepening understanding of what this Devonian area yields. So in the 20s, accidental discovery of more fossils occurred when they were doing some excavations to improve the local watershed. But by then, there were actually scientists associated with the budding new formed Cleveland Museum of Natural History. In the two to mention are Peter Bungard and Jesse Earl Hyde. Now, over the next years or so, Dr. Bungard actually reconstructed the big model of the skull, which is to the right here. And eventually the fish was renamed to honor the original curator, Dr. David Dunkel of the museum, and J. Terrell. So it became Dunkleosteus terrelli. I thought that was a little, that seemed a little unjust because this guy did all this work. But then I found later that other fishes were named after him. So Dr. Bungard was not unrecognized. He just had other fishes in his name. So what I'm going to show here is these are actually specimens from the museum website. And remember those grooves I was showing you before? I don't know if it's clear on this viewing, but you could see here outlined in red some of those linear marks, which are being now attributed to bite marks, okay? So I'm going to now show you a museum specimen on the left, unfortunately not at the same magnification on the right as my specimen, to make maybe a case. This is just an amateur, but I mean, I think I've got some bite marks here. These are very linear, different penetration, different depth in the specimen, but it's just sort of got me thinking, maybe that's another point of evidence to say this is truly, you know, a specimen from a real Dunkleosteus specimen. So the story moves quickly forward, and I'll be done in a second, but in 1966, the Ohio Department of Transportation said they were going to expand the interstate freeway. In this area, it's the Interstate 71. And they began digging, as you know, they typically do. And lo and behold, they dug into this Cleveland shale layer unknowingly. Okay, so the geologists kind of knew what was there, but no one knew how fossil laden this would be. Now, the local museum caught on right away and could marshal the resources to get to the site. And it was just literally the mother lode. And what was typical during this period is something like this. And, you know, this would be like the paleontologist's dream and nightmare. So you've got this brute strength excavating the layer, but who knows how many specimens they're crushing or just simply hauling away. So they were able to negotiate a period of study where they could marshal their forces. And there were many, many pictures such as this. So here's the field team excavating, and they excavated and retrieved a gazillion rocks. Okay, so they got in here and, you know, it was just ripe for the pickings and took everything out, which then endowed the museum with some of the best worldwide specimens of these fishes. So here they are at work. Now, the ironic thing for me is this is just a couple miles from my house. I was going away to college. All this happened before I could get back and do anything. So now it's all encased in concrete because the freeway is complete and everything's gone. So this is just to show you a couple of those specimens. And typically, you know, you go from the subterrestrial to the subterranean basements where you hope very smart and motivated graduate students and researchers are going to come back and hopefully rediscover what is there. But what is exposed and available is just phenomenal so far. Now I'm going to tie this up here in just a second because I want to show you the areas that you could go to. So this is a typical picture of the geography. And what you have is the cliffs here, the river here, and the layer we're thinking about is probably in this lower third. I'm just guessing, but that's sort of where it is in drawing on pictures of the excavations, sort of suggesting that. Here's a little better picture that shows the fuller picture of what this river geology looks like. Again, the cliffs, rather shallow water, and then broad banks. And I can't tell you how many times I walked these banks, fishing, turning rocks over, looking for crayfish, skimming rocks, and it just befuddles me to think that I was probably throwing fossils away without even knowing it. So this last picture here is very important because it's still in this general area. It's important because the most complete fossil skeleton, the skull of this fish was found in these cliffs. And this is literally just hundreds, maybe 1,000 feet away from the nature center, okay? This is called Cedar Point area. And this is a picture of the outside as you enter into the building, showing a life-size view of Dunkleosteus, and then two other specimens here below. I'll call them by their Latin names, breakfast and dinner. So these are sort of the kind of specimens this fish feasted on, although it ate everything, everything. And there was no controversy about that. I'm going to finish on this slide and then switch live again. This is actually a fossil cast to the left of the baby immature form of Dunkleosteus. Okay, so this is the lower jaw. Looks very much like the pictures and in the publication I showed earlier. It's this lower part here of the jaw on the right. Here's the fossil pectoral. So this is actually ossified as well. This is a phenomenal creature. It didn't have teeth, as I said. It had this tooth plate, but the mechanism of the jaw was most remarkable. So there was a hinge up here on the top, hinge obviously in the lower jaw, so that this opening could be enlarged dramatically. The bite force of this creature is remarkable. It was 5,000 newtons, at least according to the estimates, T-Rex being around 13,000, okay? When this fish opened its large mouth, it actually created a suction. So it would suck in the lunch or dinner and then cleave it off. A lot of the specimens were just ingested whole. In fact, a lot of the newer findings suggest from the stomach contents that the fish were just ingested and then maybe vomited out later as remnants, okay? So this is a pretty remarkable creature. Show this here because I want to show you some other thing I have. So I'm going to stop sharing and I want to show you this. Now, again, this is Zoom, so I don't know if you can appreciate. This is the two lower parts of the jaw of one of those baby Dunkleosteus. So locally, the big one's called Dunk. This one's called Dink. And the reason I'm so excited
It's a
is,
dinky dunk. Yeah.
again,
Now, is that a copy or is that a real one?
no. I wish it was, but no, this is actually a fossil cast that I obtained with the help of the president of the North Coast Fossil Group. So the Cleveland equivalent of NARG. And so he was able to take an impression and cast these for me. So I could show them to you. But I just think these are pretty incredible. Now, there's a rumor that he has actually the ability to take impressions of the whole specimen. I asked him about that, and things are pretty much on hold because of COVID. So right now, nothing that's going to happen. I'm saving my dimes up for maybe some future interaction here, but he was very generous and very helpful. But I just thought this is really cool. So this looks like what was in that photograph. Is obviously part of the specimens. I wish you could actually hold these. This is pretty cool here, at least to me. So I guess maybe what I'm trying to say is this is sort of the joy of paleontology, where you start one place and you never know quite where you're going to end up. But I now have this fuller understanding, at least, of some part of this Devonian period, more than just the trilobites and the brachiopods. So that's my show and tell.